Alright, here we are for part 3. I thought this topic would be a 2-part series. It turns out it's 3. But that's the way it goes. Alright, so I wanted this to be a continuation of the last one, which means that for the most part, I'm just going to try to work problems. I'll have to tell you some of the theoretical details and overall strategies and so on, but as much as I can, I'm just going to try to work problems. Okay, so as I go through these, though, in the videos, I think they'll get a little bit harder. And then here we are at this one. It says the 7th root of tangent of 8x secant squared 8x dx. How are we going to do that one? That one certainly looks complicated. And this is like, it's like, say, what we're doing right now, the technique is U-substitution. And so we're supposed to choose U to be something. What should we choose it to be? All right, so let me remind you of this slide I've showed you before. How do we choose what U should be? Well, you can choose U to be something in the problem such that a constant multiple of its derivative appears elsewhere. And then I see tangent, and I think, well, the derivative of tangent is secant squared, so maybe the tangent should be the U. That would be the thought process. Another thing about this is that 7th root is not exactly how I want to see this when I'm working it. So I'm going to say, well, this is tangent of 8x to the power 1 over 7, right? That's what that 7th root can be interpreted as an exponent. And that's how, all right? And then we get secant squared 8x dx. So that's probably a little bit better. But yeah, I think if I choose U to be tangent 8x, that will be the du. All right? And if that's true, that would make this a U-substitution problem. So let's say tangent 8x, that will be our U. Okay? So I'm going to make that choice, okay? And if I choose that to be U, what's du? Well, the derivative of tangent is secant squared 8x times 8 dx. We have to use the chain rule on that. The derivative of tangent of x is secant squared of x, but the derivative of tangent of 8x is secant squared of 8x times the derivative of the 8x. That's where that extra 8 comes from. So this almost works, except for that 8 right there. I mean, U's right there. Tangent of 8x, that's U. Secant squared 8x dx. This does not say secant squared 8x dx. There's an extra factor of 8. What do you think I'm going to do about that? So that it fits up there where I need it to be, I'm going to multiply this by 1 over 8. Remember, I can take this and treat it like an equation, an algebraic equation, and multiply both sides by a number or divide both sides by a number. So I'll get du over 8. And then over here, I'll get secant squared 8x dx. That's the kind of thing I was looking for. That does fit up there. So the u has a place, and secant the du has a place. So between this one and this one, I can get it to work. The objective with U-substitution is to take this problem that is in terms of the variable x and substitute it so that it's entirely in terms of u, and this will do it, all right? So I will get, let's see, u, that's tangent of 8x, 1 over 7 power, secant squared 8x dx. Okay, so that's du over 8. All right, so yes, both substitutions had their place. The integral is entirely in terms of u at this point. So that's going to be, given that this is a 1 over 8, it's going to end up being like this. Okay, yeah, that we can do. This, I mean, if you practice this enough, you can see that this is where you're going to end up. But probably that did not look very easy to you. This one is workable by some known formula. What's the antiderivative of u to the 1 over 7th power du? Well, what we do is we add 1 to that power. What's 1 over 7 plus 1? That's going to be 8 over 7. Okay. And then we divide by 8 over 7. And we had to see, that's how you do that. Once we get here, I'm not I'm not saying calculus is easy or anything like that. Some people think it's easy. But when the substitutions are made, you get something that's way easier than what you started with. Okay? So yes, when we get here, we should know what to do. My final answer. I'd have to look at this like 1 over 8 times 7 over 8. Okay? I'm going to divide by 8 over 7. That's multiplied by 7 over 8. So I'll get 7 over 64. Okay? Times, what was u? Tangent of 8x. So tangent of 8x to the power 8 over 7 plus c. All right. And there we go. That's our answer. Okay. How do we choose u? You choose u so that a constant multiple of its derivative is elsewhere in the integrand, elsewhere in the problem. Okay. All right. Now, what about this one? What do you think about this? So let's see. What were our strategies? How do you choose what you should be? By practice. All right. Most important. It probably takes practice. I can talk about this all day, but you probably won't understand it until you just practice a lot. Okay. Which may make the videos I make and all the teaching I do, maybe that makes it totally futile to do that. That ultimately you just have to practice. All right. But nonetheless, I'm explaining it. You can practice and you get good at it that way, and you'll have the right instincts, I guess, and the right experience to choose. You choose u such that a constant multiple of its derivative appears elsewhere in the problem. Let's see. What should u be, 3x? Or should u be cosine of 3x? Let's see. Well, the derivative of cosine is negative sine. I think that's the way we want it to be. But what's the other strategy? Choose u with the goal of obtaining some known formula. I think this one will be u to the 8th power. That's what I think. But I can see it either way. Now, nonetheless, I think here's how we want to look at it. Okay, with all explaining aside. Let's look at, first of all, I'll emphasize something about that. Cosine to the 8th power means that we're going to take cosine of 3x and take that number, whatever it is, to the 8th power. If I write it this way, I think it emphasizes that a little bit more. And then sine 3x dx. Okay, so let's look at it like that. I think that if you let this part be u, then this part right here will turn out to be the du. That's my thinking, because the derivative of cosine is negative sine, all right? And other than that, I think that if that works out, then my problem will become this type of problem, which that's something I know how to do. All right. Well, so let's try it. Let's try it. So in this problem, we'll let u be cosine of 3x. As a result, du will be negative sine of 3x times 3. There's the derivative of cosine 3x. Negative sine 3x times 3 times dx. So sure, I let that be u. Did du work out to be exactly this? No, I got a negative and a 3. Okay? But that's not hard to fix. Between this, I almost have what I want, but I'll multiply by negative 1/3. Okay? So look what I get then. Negative du over 3. Over here, I'll cancel the negative 3 that I have between those numbers, and I'll get sine 3x dx. All right, that's what I wanted. I wanted both of these to have a spot up there. All right, so hopefully that at this point, if you made it this far and you've seen my other videos and you've seen the problems that I've done, hopefully you're not that surprised by how I chose this and then worked through it to get it the way I need it to be. Nonetheless, all right, so let's see. That's u. Yes, cosine 3x. I chose that to be u. So let's see. U to the 8th power. And sine 3x dx, that will be negative du over 3. So let me write that this way. And what does that amount to? Negative du over 3. How do you think about what that is? Well, you think about that this way. You say that's negative 1/3 times du. There's a factor of negative 1/3. This looks like u to the 8th power times negative 1/3 times du. What does that mean we can do with the negative 1/3? Given that it's a constant factor in there, I can bring it out here to the front. Okay, and then that problem is known. We know how to do that. We should know how to do that. When we get here, it should be easy. We should know that. What's the antiderivative of u to the 8th power? Well, let's see. Carry down the third. It'd be u, you add 1 to the 8, you get a 9, and a 9, and plus c. That's what you do, right? So we'll get negative 1 over 27, 3 and 9. U, okay, u is cosine 3x, so we'll say cosine 3x to the 9th power plus c. There you go. Okay. And when I write cosine to the 9th power 3x, of course, you know, by that I mean cosine 3x to the 9th power. That's what it means when we write that exponent that way. But there you have it. Okay. All right. So let's see. Let's try this one, and then I got a few more after that. What about this one? This looks like kind of like a mess. Now, I think that for part of it we need U-substitution, but not for all of it. I'll remind you of something about rules for indefinite intervals. There's a rule that says if your integrand is one function plus or minus another, you can split a part across the plus or the minus and work each part individually. All right. So I could see this one as the indefinite integral of 4x to the 3rd power dx plus separately this other part, the indefinite integral of x squared over 3x to the 3rd power plus 1 to the 3 over 2 power dx. So it's like two problems. This one will be fairly easy. This one will take U-substitution. Okay? So let's see. I'll say this. I'm not worried about that one. Okay? This one, on the other hand, let's do this. That's a U-substitution problem. If you let u be this part, 3x to the 3rd power plus 1, what's the derivative of 3x to the 3rd power? That would be 9x squared. Well, that's x squared. So I think between, like that, this will be the u. Okay? And I think this part, the x squared and the dx, that'll be the du. All right, so that's what I'm seeing, that it'll go that direction. Okay? If I do that, like, so that's my objective. That's what I think is going to happen. Then I'll let u be, as you see there, 3x to the 3rd power plus 1. Du as a result will be 9x squared dx. Here I have x squared dx. All right? I can look at this like 1 over 3x third plus 1, 3 over 2, times x squared times dx. Okay? So I don't quite have it. Let me write one more step. Just to make sure that hopefully we don't miss anything when we're looking at this. I'm going to split this apart. You can see it this way. 3x 3rd power plus 1 negative 3 over 2 times x squared times dx. That's everything, all right? But I wanted to like split it apart and make sure that you saw each 3 factors. All right, so yes, I've got u right there. I almost have the du, that x squared dx, almost, except for the 9. So we can say du over 9 is x squared dx. Yeah, so this and this, that's what will work for us. Okay, so let's carry over into the next step. Okay, now this one, I don't need U-substitution to do that one. It's simple enough that I can do it the way it is. This one ends up being u to the negative 3 over 2 power Okay? And then that x squared dx is du over 9. Okay, let's see. One more step. I'll carry this. Worry about it in a minute. I'll take out that 1 over 9. That 9 right there is a 1 over 9, which I'll remove this way. Okay, so now I got it. I got this the way I need it. That one is x to the 4th power. Is it true the derivative of x to the 4th power is 4x to the 3rd? Yes. Okay, so that's done. Over here, 1 over 9. Okay, this is workable by some known formula. Here's what I do. I add 1 to the power. Negative 3 over 2 plus 2 over 2 is negative 1 over 2. All right. So that's this part. And then I'm done at that point. I say plus c. Okay. Final answer. Let's see. So I got this x to the 4th. What's 1/9 times the reciprocal of negative 1/2? If I'm dividing by negative 1/2, that's the same as multiplying by 2. So I'll say negative 2 over 9. And what was u? 3x to the 3rd plus 1. 3x to the 3rd power plus 1 to the negative 1/2 plus c. All right, that's okay. Who knows? You might be required to write the answer this way, so just in case, I'll say 2 over 9, and let's do root 3x to the 3rd plus 1, because that's a negative 1/2. If I move that down here, it would be an exponent of positive 1/2, but then that exponent is the equivalent to the square root. All right, there we go. Okay, so let's look at now something a little bit different than all of them I've showed you. I guess this one doesn't really look like it'd be extremely difficult or much harder, but let's see. Okay, now with this one, you probably think that just because of the exponent, you see that 9 there, that if it's like the others, it probably reduces something like this. Okay? All right, that would be a natural thing to think. So say I choose u to be x minus 1 with the intention of making that happen, because I think that's the kind of problem it's going to be. So I choose this u like this. That's my choice. As a result, du is equal to, what's the derivative of x minus 1? It's 1. So du is equal to dx. Okay. Now, the objective, though, when we do this, when we do U-substitution, is to entirely transform the integral from being in terms of x to being in terms of u. Okay. So remember, here's the outline of the method. We choose a substitution. U is f of x. Then du is f prime x dx. So far, we've done that. But we want to substitute in a way that the integral that we have only involves the variable u. So say that I did that so far. It doesn't look like there's a way to use that one. Like if I just substitute what I have, I get x. Now x minus 1, that's u. X times u to the 9th power. And then dx, sure enough, that's du. So it's like almost works. Okay, but I just want you to know that when you're doing this, when you're doing problems by yourself, you need to choose the substitution, but ultimately the problem you're going to have to work is in terms of x or it's in terms of u. It can't be some mixture of both. So I need all x or all u. This is a mixture of them. So is there any way that I could get that x out and put it in terms of u? Because that would be the objective, to get it completely in terms of u. Well, I could treat these like algebraic equations. If I let u be x minus 1, I could add 1 to both sides of this, and u plus 1 would be x. So yes, between all three of these, okay, it takes all three of these to get that to work. Here's what I'll get. Okay, x minus 1, that's u. I get u to the 9th power. X is u plus 1. And then dx is equal to du. Okay, so I need all x or all u. It took a little, I just solved that for x, basically. I remember these are, I could treat these like algebraic equations if I needed to. I could modify them like that. So I needed this to be in terms of x or u, all x or all u. In other words, I needed to get to this point, okay? All right, now how can we do this problem? Once we're here, the way that we work it is, let's see, we'll distribute this in there. So that will be a 10. And this will be u to the 9th. And then individually, these can be worked like this. The antiderivative of u to the 10th power is u to the 11th power over 11 plus antiderivative of u to the 9th power, u to the 10th over 10 plus c. Okay. My final answer then, given that my original substitution was that u is x minus 1, I'll get x minus 1 to the 11th power over 11 plus x minus 1 to the 10th power over 10 plus c. All right. So that part right here is what makes this one a little bit different. If I didn't realize that how or that I was supposed to modify that, I'd be stuck here. And the way these work is you either work the problem with the variable x, or if you can't do that, you work the problem with u. But some mixture of them is not the way to go. All right. So, all right, that one is, for that reason, is a little bit different. I wanted to do another one kind of like this then, just because it is different, all right? So here with this one, I think this is a lot like the last one, especially if I see this root like that, okay? So I think I'll let that be the u, and I'll get the rest of it to be the du somehow. All right, so let's see. I'll let u be 4 minus x. Okay. Du, as a result, will be negative dx. I've got dx, not negative dx. So I'll multiply both sides of this by negative 1. And it turns out I'll be working with negative du is equal to dx. Okay, so far so good. I got that will be u. I can substitute that, okay. And this will be negative 1 times du. What about this other thing, x plus 3? How am I going to substitute that? Okay. Well, let's see. Let's substitute just the x. All right. So say I work that out a little bit. I move the x to the left and the u to the right. It will say x is equal to 4 minus u. Now, so between this and this and this, I can substitute everything. I can get it completely in terms of u. All right. So if I do that, imagine these substitutions in this step. All right, here's what I'll get. X, that will be 4 minus u, plus 3. And then 4 minus x, that will be u. Dx, that will be negative 1 times du. Okay, now this is entirely in terms of u, and I think it's one that we can work. All right, so okay, let's see. I will get a negative 1 right there that I'll factor out to the front. This will be 4 and 3, so let's do 7 minus u, u to the 1/2 du. To take it further, in order to work this, I need to distribute, okay? So I'll get negative 7u to the 1/2 power minus u, what would that be? 3 over 2. Okay, and now I can work it. I have a rule for this when I get to this point. All right, so here's what we do. So that 7, that's a constant. So I'm going to get like this. Let's see. That negative applies to the entire answer to this. 7u, add 1 to that. 3 over 2. 3 over 2. Okay. Minus u, add 1 to that. 5 over 2. 5 over 2. And then I'm all done. I add my constant of integration. Okay, a little bit of cleanup. Let's see. 7 times 2 over 3. So that's going to be 14 over 3. Okay? U, 4 minus x. 4 minus x to the 3 over 2 power. Okay? Over here, that negative applies all throughout this. I'll make it a positive. That'll be 2/5. Okay? U, 4 minus x, power 5 over 2 plus c. All right. There we have it. Okay. Negative 14/3, 4 minus x, power 3 over 2, minus 2/5, 4 minus x, power 5 over 2. And then always plus c, plus the constant of integration. All right. So compare this one with this one. I did them in almost exactly the same way. Okay. All right. Let's do one more. So solve the differential equation. So that might be the only statement about a question like this, but it says something like this, along these lines. There's this function y that we don't know, okay? The derivative of it is equal to this. And furthermore, maybe a graph is provided with some information or some points or something like that. So here's the question. I'm looking for this function y. I know that it has this point 2 for x, 12 for y on the graph. And I know its derivative is this. How do you find that original function? If you know a point or some numbers that work in the function, and if you know its derivative. Okay? All right. So think that I have this, and I want that. So first thing, the way I would find y, if this is its derivative, this is the antiderivative of that. Okay? So y would be the antiderivative of x times x squared plus 5 to the 1/2 power. Initially, that's the way it would be. Like this is what you're looking for. Okay, well, that's initially how you find it. How do you do this, though? What's the technique? This is a U-substitution problem. That will be U, and what's the derivative of x squared plus 5? It's 2x. Well, I got x. I'm missing the 2, but I can work with the 2. I can get the 2 in there where I need it. So I'm going to do this by U-substitution. I'll get U is x squared plus 5, and du is 2x dx. All right, so I got, like I said, I got x dx. I'm working with 2x dx here. I'll divide both sides by 2. So I get du over 2 is x dx. Okay, now that substitution will give me a way to do this one. I want to use this. I want to use this, okay? So right in there, I'm going to get u to the 1/2 power, and then x dx, that'll be du over 2. Okay, from here, about that 2 right there, we'll factor it out. And that will leave me like so. And then now I can work that one. I've got a technique for it. There's a formula. You add 1 to this power and you divide. So I'll get 1/2 u, and if I add 1 to that, I'll get 3 over 2 and 3 over 2 and plus c. So it looks like my answer is that y is equal to 1/3 x squared plus 5 to the 3 over 2 power plus c. Okay, so what was that function whose derivative is this? Here it is. 1/3 x squared plus 5 to the 3 over 2 power plus c. That's the function, all right? But this is incomplete. So let's do like this. I call this step 1. What's incomplete about it? What is c? What is this number? All right, what should that number be? Sure, if you take the derivative of this, because that's just a constant, even if I don't at this point know what it is, it will zero out and you'll get that. What else do we know about this function? Well, we were given its graph. And if some points are labeled, like I could, for example, say, well, in this function, when you put 2 for x, you will get 12 for y. Okay, so that will allow us to find c. So we'll say for step 2, for that function right there, if, what was it, x is 2, then y will have to be 12. Okay, so we can use that to find c. So watch what happens if we do that. All right, so y is 12 whenever x is 2. And that's enough information to figure out what that number c should be. All right, so let's see, 12, let's see, so that's 9, right? Square root of 9 is 3. 3 to the 3rd power is 27. 27 divided by 3 is 9. Okay. So we want, let's see, 12 is 9 plus what? C is equal to 3. Okay. So our answer, the function that has this derivative and also is such that when you put 2 for x, you get 12 for y, is this with 3 right there. So let's write our answer up here. Y is equal to 1/3 x squared plus 5 to the power 3 over 2 plus, what do we find c to be? 3. So plus 3. There's our answer. Verify it, okay? You go ahead and verify it. If you take the derivative of this, you will get that. And if you put 2 for x, you will get 12 for y. It does everything that was given to us, and that's what makes it correct.